Hi everybody, today we're going to talk about gas laws and stoichiometry. So we've been studying gas laws in this chapter, and the main gas law is the ideal gas law, which is PV equals nRT. We've studied calculations before with stoichiometry, and stoichiometry is basically calculations in chemical reactions. The main thing about stoichiometry is the molar ratio. So you can link between one substance and another using that molar ratio, which is the coefficients in the balanced chemical reaction. So what is the link between PV equals nRT and then calculations in chemical reactions? Well, the link is moles. So we're going to do one of two things in these calculations. Either we're going to have a gas, and we're going to be given information about that gas in order to calculate the moles of the gas, and then using the moles that we got from PV equals nRT, then we're going to use those moles to go to moles of another substance, and then maybe to grams or to molecules or whatever else. So either we're going to use PV equals nRT, get the moles, and then use those moles in other stoic calculations, or the other option would be to use stoichiometry to get to moles of gas, and then once we have the moles of the gas, then we can plug it into PV equals nRT to either find the pressure, the volume, or the temperature of that gas. So let's take a look at an example. So example 1 says, what mass of NaCl could be produced from excess sodium and 10 liters of chlorine gas at 23 Celsius and 1.02 atm? Since it's talking about a chemical reaction, we would want to write the balanced chemical equation. And so I'm going to do that. So NaCl produced, so that means NaCl comes after the arrow. And my reactants are sodium, which is Na, and then chlorine, which is Cl2, because chlorine is diatomic. Let's balance it. So we need 2 sodiums, 1 chlorine, and 2 sodium chlorides. I also like to write down what I have. So I'm asked for what mass of NaCl, so I'll put question mark grams here. I'm given 10 liters of chlorine. I'm given excess sodium, which means I have a lot of it. It's not my limiting reaction. I don't have to worry about it. My chlorine are 10 liters. And I'm given a temperature and a pressure. Now, this reaction happens, the whole thing happens at this temperature and pressure. So the temperature and pressure apply to everything. However, really pressure especially does not matter in any calculations except for gases. And so even though the whole reaction happens at that temperature and pressure, my gas is the only thing affected by these things. And so if you look at, my sodium here is a metal and it's a solid at room temperature. My NaCl is an ionic substance, and so that means it's a solid at room temperature as well. So my only gas is the chlorine. So only chlorine is affected by that temperature and pressure. So I'm going to write them down under the chlorine. So 1.02 atm. And then my temperature, 23 Celsius, I'm going to convert that to Kelvin right away. So 296 Kelvin. And let's think about what we're trying to find here. So we're trying to find the grams of the NaCl. However, I'm not given any information about NaCl. The only substance I have information about is the chlorine. To link between two different substances, I can use the molar ratio from the chemical equation. So in stoichiometry, whether it's a regular stoic calculation like we've used to do before, or a gaseous stoichiometry, or solution stoichiometry, or any kind of stoichiometry reaction, there are 3 steps that you follow after you balance your chemical equation. First, you find the moles of the substance you have information about. In this case, it will be the chlorine. So first I find moles of chlorine. Then you find moles of the substance you're interested in. So in this case, I would find the moles of the NaCl next. And then the last step would be to actually answer the question, which would be to find grams of NaCl. So I'm going to go ahead and write these steps for you here. So here are the 3 steps up here. Find moles of the substance you have information about. Then find the moles of the substance that you are interested in. that you were asked about, and then answer your question. So again, we're going to find moles of chlorine, then moles of NaCl, and then the grams of NaCl. So how do we do that? First, we want to find moles of chlorine. So let's think about it. We have volume, and it's a gas. It's not an SDP though, but we do know the temperature and the pressure. So we could use PV equals nRT. So PV equals nRT. My pressure is 1.02 atm. Volume is 10 liters. N is what I'm solving for. And actually, whenever I write PV equals nRT, I like to write what substance I'm doing this for a couple of reasons. So I don't lose track of which one I'm finding the moles for. Also, because sometimes by mistake you will do PV equals nRT for something that's not a gas, like a solid, for example. And so this will remind you, if you write, PV equals nRT and then right next to it NaCl, hopefully as you're writing NaCl, you think, oh, that's a solid. That's not going to work for PV equals nRT. It's not a gas. So anyway, N is the moles of Cl2. That's what I'm trying to find. My R is 0.0821 atm times liters per mole Kelvin. And my temperature is 296 Kelvin. I end up with 0.4192. Or sorry, that's 0.197. I'll round to 6 figs at the end. This is moles of chlorine, since I did PV equals nRT for chlorine. So I found moles of chlorine. Now I'm going to link it to my NaCl. So to go from moles of one substance to the other, use the molar ratio from the equation. So I'll put moles of chlorine on the bottom, moles of NaCl on top, and it's a 2-to-1 according to the equation. So right now I have moles of NaCl, and then I answer my question at the end. So I'm going to go from moles of NaCl, 2 grams of NaCl, 23 and 35.5, so 58.5 grams. So my answer is 49.1 grams of NaCl. And that is my answer. Let's try another problem. Example 2 says calcium carbonate decomposes to form carbon dioxide and calcium oxide. What volume of carbon dioxide at this temperature and pressure is produced if 25 grams of calcium carbonate is decomposed? Long problem. First thing I do is I write my chemical equation. So calcium carbonate is CaCO3, decomposes to form carbon dioxide, which is CO2, plus calcium oxide, CaO. It's already balanced. No fun. I'm going to write down what I have. So it's asking what volume of carbon dioxide and it's giving me 25 grams of calcium carbonate. I also have a temperature and a pressure. Now if you look again, calcium carbonate and calcium oxide are both ionic, so they're going to be solid at room temperature. So my temperature and pressure are only relevant to my carbon dioxide. So I'm going to write them down under carbon dioxide. And again, I'm going to convert my Celsius to Kelvin. So 298 Kelvin is 25 Celsius and 99.8 kPa. So I am trying to find the volume of my carbon dioxide. It's a gas, and I'm given the temperature and the pressure. So maybe I can plug it into PV equals nRT. Now, if I do that, I do have my pressure. Volume is what I'm looking for. I don't have amount, and I do have temperature. So I'm from PV equals nRT, I'm missing the V and the N, so I can't really use it at this point. However, I am given some information about the calcium carbonate here, and since it's mass, I can figure out what the moles of the calcium carbonate are. Then I can go to moles of CO2, and then once I have the moles of CO2, then I have the N for my PV equals nRT. So I'm going to start with my substance that I have information about to find its moles, so moles of calcium carbonate. Then I'm going to find moles of the CO2, and then I'm going to plug it in to find the volume of the CO2. So my 3 steps. So first step, find moles of the substance you have information about, which is the calcium carbonate. So 25 grams of calcium carbonate. Molar mass on the bottom. So 1 mole on top. Grams on the bottom. And we're going to add up a calcium, a carbon, and 3 oxygens. And that turns out to be 100 or 100.1 grams. That gets me to moles of calcium carbonate. Next, I'm going to go to the moles of the substance I have information about, which I can do by the molar ratio. So moles of calcium carbonate on the bottom. Moles of CO2. In this case, it's a 1-to-1. And so this gives me 0.25 0 moles of the CO2. I'm sorry. Now that I have moles of CO2, I can plug it into PV equals nRT. And I'll do that for CO2. That's my gas. So my pressure is 99.8 kPa. Volume is what I'm looking for. And I figured that out. It's 0.25 moles. R is 8.31 kPa times liters per mole Kelvin. And my temperature is 298 Kelvin. And I got my volume to be 6.20 liters of carbon dioxide. So I want you to look real quick at what we did here versus in example 1. So in this example, oh, I don't know why this is moving there, but it's okay. So in this example, in example 2, I used stoichiometry first, right here, and then I plugged into PV equals nRT. If you look at example 1, I used PV equals nRT first, and then after that I did stoichiometry. But the link here, again, is the moles. So you either do PV equals nRT to find the moles of a gas, then you use stoichiometry, or here we use stoichiometry to find the moles of a gas, and then we plug it into PV equals nRT. And in all stoic problems, you find the moles of the substance you have information about, then the moles of the substance you're interested in, and then you answer the question. All right, hope to see you guys tomorrow in class. Have a great day.